It's wonderful to be back in Silicon Valley. As was just mentioned, there are a few gray hairs in the room, which is good because those people over the age of 30 remember when newspapers were a thing. And there was a time when the San Jose Mercury News was a thing because if you wanted to find a job or a house or a car, you actually had to get to a newspaper to find the classified ads. And in that era, the Mercury News was a fairly important institution, and I was very proud to work for it and write about technology and Asia and trends in this part of the world. Oxford, very briefly, is one of the world's leaders in macroeconomic research and forecasting, and I spend a lot of my time putting economic principles into actionable insights. So I mentioned the fact that we're in an internet era, and I'm assuming all of you have now Samsung-enabled, internet-enabled Samsung TVs, and I'm wondering if any of you might have seen this Netflix documentary called American Factory, which is notable not only because it was produced by Michelle and Barack Obama, but it's also now a finalist for an Oscar in the documentary category. It's actually a fascinating look at the economic and cultural clash that appears when a US auto plant in Ohio shuts down and is replaced by a Chinese firm that hopes to make auto glass for automobiles and wants to hire back many of the old UAW workers. It's a complicated and sometimes profound tale of good intentions and cultural friction and miscommunication as industrial workers struggle with forces beyond their control, including corporate downsizing and globalization, trends we hear a lot about. But how many of you remember how this movie ends? It ends with, in the last scene, the pallets are arriving, dropping off robots. And the robots are smart machines that perform manufacturing tools far more effectively than humans can. And it's a powerful and even disturbing moment when you realize these workers may not have long for this factory. The productivity of the factory will clearly increase. The owners will turn red ink into profits. But the workers in Ohio, and ultimately their counterparts at a sister factory in China, face a dauntingly uncertain future. Those of us who work in economics believe technology and innovation help grow the size and grow the pie of the economy. That economic outputs make everybody in society wealthier and it benefits all. The question we want to ask in our work about automation and robotics is this wave of technology different? We know that some workers will thrive, but the outlook for millions of workers around the world remains kind of an open question. And the question we want to ask is, how will this technology dividend that's derived from automation and robotics, how will it be divvied up? These are the questions we set out to map, model, and better understand in our research. In the emerging reality, we detail in a report we published last summer called How Robots Change the World. Machines animated by software that can learn and interact with its environment replace workers in jobs once held by humans. Today, it's manufacturing. Tomorrow, transport and logistics, as we believe autonomous vehicles become more reliable. And then service jobs, and ultimately, perhaps, knowledge work. This is, of course, an age-old trend. It's why we work in technology in the first place. And humanity has adopted time after time to these kind of changes. It's important to remember that something like half of all adults were agricultural laborers at the start of the 20th century. Today, it's less than 5%, and we eat healthier and better than ever. And we feed the world and remain employed. So humans find new and often better things to do. But we want to understand, using our economists and econometricians, what this would mean for the future. The question this time is whether it may be different for millions of workers around the world. The historical imbalance between the positive and negative effects of automation have significant social and political implications, as we see by the Yellow Vests movement in France, by the Brexit situation in the UK, and yes, by discussions of populism and anti-trade rhetoric here in the United States. So we at Oxford set out to understand what this new wave of smart automation really means. Our report was the product of 2 years of work by a global team of economists and analysts. It provides a detailed look at the impacts of robots. Now, I'm want to emphasize we're talking physical machines and not RPA. On the manufacturing sector across several countries, and include a robot vulnerability index, or an RVI, that quantifies the impact across several advanced countries. The report also looks ahead to the rise of robotics in the service sector. We see robots and AI bringing a considerable benefit, starting with meaningful gains in productivity. Many jobs will be safer, many regions, companies, and individuals will grow wealthier. Yet, the transition to an automated economy will be jarring because neither human lives nor careers are fungible goods. And the people who get new technology-driven jobs will be, for the most part, not be those who lost jobs in the transition to machines. New jobs may offer less pay and security, and wealth inequality will likely grow. The challenges for education and public policy are huge. So I want to now discuss some of the ways in which we think robots are going to change the world. And I'm going to discuss it in basically 7 little frames here. One is this robotics revolution, the impact on jobs, what we call the robot vulnerability index, the robot dividend and how it's going to be spread out, what robots mean for the service world, and then some discussion of what the framework for action might be. So let me first discuss the robots revolution. This chart shows the rate at which the number of new robot installations has risen globally since 2010. In that era, we've seen an 11% drop in the unit prices of robots. At the same time that each unit has become cheaper, it's become a lot more powerful. Our chart, if you look at this chart closely, it shows the impact of China, China, China. The dark blue bar is China, which accounted for 36% of global sales in 2017, up from 30% in 2016. China now accounts for 1 of 5 of the world's active stock of robots, up from 0.1% in 2000. Robots are rapidly becoming more capable. They're being installed in ever more sophisticated processes, they're placed in more varied contexts, and can be installed and reprogrammed much more rapidly than ever before. Today's robots are smaller, more sensitive to their environments, and much more collaborative thanks to AI. They can learn from their experiences and make decisions informed by data from a network of robots. This has propelled robot installations in a wider range of sectors than what we usually saw before. This chart shows the growth in robot installations is much faster in new emerging sectors than just the automotive sector, which was traditionally the hive and driver of robotization. The major reason for growth in demand, as I suggested before, is the growth of the Chinese economy. As the consumer economy grows, the demand from the Chinese market for manufacturing goods rises, and at the same time, Chinese manufacturers need to find more productive ways to supply them because in China, as in the United States, the workforce is aging and the wages are rising. China is no longer the sweatshop of Asia. China has become the world's largest automotive manufacturing site and a major producer of consumer electronics, as I need not tell people in this room. And everything from batteries to semiconductors are now being built there, and those are all highly robot-sensitive manufacturing sectors. And this trend is set to continue. This chart shows how, despite having the world's largest stock of robots, in absolute terms, its manufacturing sector is only at the beginning of its automation journey. China uses only 68 robots per 10,000 workers in manufacturing today, compared with 303 per 10,000 in Japan, and 631 per 10,000 is the robot density in South Korea. So the potential for growth in China is enormous. The large sections of China's workforce are still engaged in manual processes, and therefore there's vast potential for robotization in China to displace those jobs. So let's talk then about the impact on jobs. We developed an econometric model to explore the impact industrial robots have had on jobs since the turn of the century. We wanted to see how these jobs are distributed across different parts of the labor market and what that means for wealth and inequality. And we wanted to ask what the future might hold. So let me go ahead and show you some of our main findings. Since 2004, each new industrial robot installed in the manufacturing sector has displaced an average of 1.6 workers from their jobs. This is a baseline estimate only, since over time, as machines learn and become more integrated into workflows and the learning curve effects take hold, this displacement number could easily grow. The full impact takes time to materialize. Roughly 1.3 workers are displaced in the first year of a robot's installation on average, but this extends to 1.6 workers over subsequent years. This finding is consistent with industry evidence of lagged productivity gains as companies invest in training and reorganize production processes around technology. The chart also shows what this implies in cumulative terms since the turn of the century. Controlling for other drivers of manufacturing employment, such as offshoring and globalization of supply chains, we estimate that around 1.7 million manufacturing jobs have been wiped out since 2000 due to the global rise of industrial robots. That's more than 26,000 jobs in the US, about 2% of the manufacturing workforce, about 400,000 jobs in the EU, about 1.5% of the workforce, and more than 500,000 jobs, 550,000 jobs in China, which is about 1% of the manufacturing workforce. Assuming robot investments continue at their current pace, we estimate that almost 20 million manufacturing jobs could disappear around the world in the next decade as a result of robotic automation. That's projecting the growth in active robot stock in major manufacturing economies based on the 3-year growth projections developed by the International Federation of Robotics, and accounting for the need to replace deteriorating robots over the time. So it's not just new, but it's also replacement numbers. Put differently, if these current trends hold, the global manufacturing workforce would be 8.5% smaller by 2030 than it is today as a result of robot installations. Just as important, the great displacement that we project in terms of jobs will not be evenly distributed. On average, a new robot displaces nearly twice as many jobs in lower income regions compared with higher income regions of the same country. This chart shows how the average effect is in each additional robot installed displaces 1.6 workers, but that in lower income regions, it rises to 2.2 workers per additional robot, while in higher income regions, it's just 1.3 workers per additional robot. What might explain this? Well, we believe it shows the underlying issue of productivity. Manufacturing operations in lower income areas tend to use lower skilled workers who are paid less, and their roles are more susceptible to automation. The UK labor force survey, and remember my company is based in the UK, it shows that about 1/3 of manufacturing workers in lower income regions of the UK exist in lower skilled occupations such as elementary workers and machine operatives. That compares with 22% in higher income regions. In contrast, a significantly higher proportion of the manufacturing sector's managers and professionals are located in higher income regions. High value work tends to congregate in areas with higher costs. Look at Silicon Valley and look at why you're here. At the time of worldwide concern about growing levels of economic inequality and political polarization, this finding has important social and political implications. As I mentioned, Brexit, yellow vests, populism, they all stem from this sense of growing insecurity. And it implies that the trend to greater robotization will not ease, but actually aggravate the social and economic stresses that we see in major economies today. So this made us think about which regions of the countries and of countries would be most vulnerable to robots. So we at Oxford Economics developed a tool to help shape the way policymakers might consider how the costs and benefits of robot adoption might be distributed and help plan for the consequences of this potential inequality. This Robot Vulnerability Index identifies regions within countries that will be hardest hit by the ongoing robotization and automation of their manufacturing sectors. We focused the study on a number of major economies, including the US, Germany, UK, France, Japan, South Korea, and Australia. and our report includes detailed maps for all of them, but in this presentation, I'll just focus on a few. So what makes a region vulnerable to robots? We measure three things that are important. This index is designed to highlight regions that are economically dependent on a less productive or lower skilled set of workers in the manufacturing sector and do not currently use highly advanced manufacturing technologies. There are aspects that a region at higher risk of an economic upheaval from industrialization and robotization share that are different from others. The three measurable drivers are, as this says, local dependence on manufacturing employment, future readiness of local industry, characterized by the current intensity of industrial robotic use in the region, which we measure relative to their international competitors, and the productivity of the local workforce as a proxy for the average skill level it embodies. This is measured relative to the national average. So what does the RVI reveal? That existing geographical inequalities within countries look set to intensify over time. Simply put, the rich will get richer and the poor will get poorer. The most vulnerable regions are distant from the wealthier districts of our featured countries. For example, major cities are relative safe havens for manufacturing workers because these are diversified economies which are less dependent on manufacturing and have higher average skill levels in the workforce. On the other hand, the future of manufacturing-intensive cities is less certain. RVI flags that cities with large populations dependent on the manufacturing center in which their industry lags their peers in productivity will face difficulties, and fierce competition may inevitably lead these manufacturing companies to move to robots or to shut down. Either way, making the workers vulnerable to future job displacement. And rural communities are actually more vulnerable than you might think. Many rural economies are grounded by isolated towns with more manufacturing-intensive industrial outputs, and the decline of our manufacturing space makes them difficult to weather the storm. Our rural areas tend to have low-value, labor-intensive techniques and dated manufacturing processes, and displaced workers in these communities are potentially disenfranchised from the generations of new jobs that might take place in the cities or more prosperous areas. So let me show you a few of these charts. Here's the RVI for the United States, which shows, for instance, that New York, which is a highly diversified, high-service economy, much like San Francisco, has a sizable manufacturing center, but high concentration of financial and business services make it far less vulnerable to robots, whereas Eastern Oregon, for example, has difficulty because it has high dependence on manufacturing and exposed to globally competitive forces, whereas states like Florida, Nevada, and Hawaii, which are more service-oriented and more involved in tourism, have a less vulnerability to robotics. Here's Germany. The former parts of the old East Bloc, closer to Czechoslovakia, are far more vulnerable to robotization than Hamburg, which has low dependency on manufacturing and where the manufacturing skills are highly advanced. There's a lot of productivity already and already a great deal of automation. And we think that Bavaria and Stuttgart, where BMW and Mercedes are bent, have already, because they are so globally competitive anyway, have already made their production systems far more future ready. The UK, again, like Manhattan, London is far less vulnerable to robotization because it's very well placed for the next phase of robotization. The manufacturing operations are pretty advanced, and they have a productive, diverse economy, whereas Cumbria is sparsely populated rural region, and those towns that have manufacturing are still doing manufacturing that's not terribly advanced. So they could be easily displaced. Because I'm at Samsung, I had to include South Korea. Seoul, as you would imagine, and where our company is headquartered, is the financial and service capital of the country. It has a diverse employment base and high productivity. We don't think it's particularly vulnerable to robotization. Whereas Incheon and Daegu, which have always suffered from relative regionalization, have relatively low labor productivity, and Daegu, we know, has long suffered from relatively low investment, whereas Busan and Ulsan shipbuilding, steel centers, they're still manufacturing dependent, and there's still some possibility of robotization, but not to the same extent as Incheon. So let's talk about the wealth that robots are going to create, or what we call the wealth dividend. Our modeling shows robots have delivered considerable productivity gains in recent years. We analyzed impact of robot densification on productivity growth in 29 countries over 11 years, controlling for factors such as skill levels and other capital investment. We found that a 1% increase in the stock of robots per worker in the manufacturing sector leads to a 0.1% boost, a 0.1% growth in output per worker across the wider workforce. In other words, installing an additional robot per 100 workers in the US manufacturing center would boost GDP by $185 billion. By displacing jobs in manufacturing, robots liberate workers from automatable tasks to contribute more productivity elsewhere in the economy. And that this leads to faster GDP growth. Robot densification, we explored the implications of this densification, and we have our own global economic model that is the foundation of all of our forecasts for both industries and cities, and it enabled us to test the sensitivity of macroeconomic outcomes to different rates of investment. We established a baseline GDP consistent with short-term robot investment trajectories forecast by the Robotics Institute, the IFR. We then developed a high and low scenarios for robotization. The high scenario assumes global stock of industrial robots will accelerate 30% above baseline projections in the next 10 years by 2030. For China's manufacturing sector, this would put its robot density on a par with the levels of robot density that now exist in Japan and Germany. The low scenario assumes the pace of robot adoption slows, leaving the stock of industrial robots some 30% lower than the baseline in 2030. We found that faster adoption of robots has a significantly positive impact on both short and medium economic growth. The high adoption scenario would boost global output, global GDP, by 5.3% above baseline by 2030. This means adding an extra 4.9 trillion to the global economy, which means adding the GDP of Germany to global output. That's equivalent to an extra $575 of gross value added per person in the world. This next chart shows the results of modeling for China, the US, EU, Japan, and South Korea. A 13% increase above baseline for the US GDP, an 11.7% increase in South Korea, a 9% increase in China, but for Japan, relatively lower gains and losses because of the slower rate of robot investment taking place there, which reflects the fact that Japan's already done a lot to put robots into its output. Now, expanding the economy creates jobs too. It does not just job losses. New demands for workers are derived from additional demand for goods and services that a growing economy generates. More GDP means more demand. This doesn't necessarily do much good for people who lose their jobs, however. Those new jobs may be out of reach in terms of geography or skills. People may not want to move and they may not have the right training. And new jobs often do not pay as well as old manufacturing line blue-collar jobs did. So what will this mean for the next generation of displaced workers is a fair question. Well, sometimes they would move into service, but we know that we're seeing robots move into the service world as well. Large-scale displacements from manufacturing have traditionally been soaked up by the service sector, but manufacturing accounts for only a minor share of total employment today, whereas service accounts for 3/4 of employment globally. So if robots are now steadily gaining traction in the service sector too, what are the implications of that for our future? Indeed, the next frontier is robotics in the service world. More than half of the workers leaving production jobs in the past 2 decades in the US were absorbed in just 3 areas of occupation: transportation, construction and maintenance, and office and administration. But these are also the occupations most vulnerable to automation in the next decade. as robots move into the service-oriented sectors. According to our own research, the impact of technology change on the service sector and on the U.S. labor market, especially those areas that have been traditional safety valves for those losing blue-collar jobs, are being taken over by robots. Taxis and truck driving is a good example, where we all hear about autonomous vehicles. Now, I know some of you in this room are actually working on that challenge, and we believe that the adoption of autonomous vehicles in long-haul trucking and in things like taxi driving will take place more slowly than the headline suggests, but that they will take place pretty steadily. So it's in service robotics. We see a significant acceleration some of the most exciting developments today taking place. So I'm going to describe some of what we're seeing in the service robot sector. First, of course, is healthcare. Robots are already being used to reduce the workload of nurses who are already stressed and for whom there's already a nursing shortage in the United States. Robots can deliver samples to a lab, fetch prescriptions from the dispensary, and take on other routine tasks. This allowed nurses to spend more time on the caregiving for patients and compassion, the things that robots aren't too good at. Because there's a nursing shortage in America and other developed countries, we don't think the addition of robots creates such a political challenge. It's mostly been welcomed by hospitals and by administrators. Construction and farming. As many as 30% of cows in the EU today are now being milked by robots. So robotics in agriculture is becoming more commonplace. The machines can milk cows 4 times a day versus just twice for humans. These innovations are useful because farming in advanced countries like the EU and US face a chronic shortage of workers. Again, we don't expect a lot of pushback against robots in the farm sector. New kinds of robots have already been built to lay bricks and install sheetrock, and we've discovered a robot that can now lay some 3,000 bricks per day. But these will be mostly used in confined and controlled environments with an otherwise busy and sometimes chaotic building site where they're being used in a very discrete manner. The next trend is in transport. As I said earlier, we believe that disruption is less imminent than press reports or Elon Musk on Twitter would suggest. Long-haul trucking transportation may be among the first sectors significantly disrupted by AI-powered robotic transportation. These jobs are often routine, station-to-station routes, so automation would seem relatively structured. Expectations that AI-powered trucking systems will be operating by the end of the decade, I think, are reasonable. Autonomous vehicles won't just be on the roadways, however. We found a shipping company in Norway, Kongsberg Maritime it's called, that is already experimenting with an autonomous vessel that will deliver fertilizer using a battery-operated, solar-generated ship. Hospitality. We've already seen major experiments taking place employing robots in place of humans to check guests into a hotel, make room service deliveries, or prepare food in some restaurants. Although we've also seen in the past couple of weeks that the robot pizza shop in San Francisco didn't quite make it and closed its doors. So there are a few cautionary tales. One Las Vegas hotel we spoke to reported an enthusiastic response from the human bell staff because the workers could give the robots the most routine tasks, which don't usually generate a good tip, and leave the more profitable jobs for themselves. AI systems can help automate check-in and check-out and notify the cleaning staff through motion sensors when rooms are unoccupied. This would also lead to productivity gains. Retail. The use of scanners and barcodes we've already seen. They've already replaced thousands of retail payment clerks. Amazon has, as you all know, begun operating convenience stores without any clerks at all. A number of retail chains are experimenting with robots that can guide shoppers to find products in a store or can scan shelves continuously to monitor inventory. Robots are already heavily in use in retail distribution systems led by Amazon, which has invested heavily in the sector. It remains unlikely in the near term, however, that robots will actually stock shelves, as getting arms and fingers of the robots to work flawlessly remains kind of a challenge, the grasp problem, as it's referred to. Deployment of robot cleaning systems like vacuums can be expected in the near future in big hotels where there's sufficient scale. It remains to be seen, however, whether humans will be attracted to or repelled by properties which employ robots instead of humans. There's a host of applications beyond the reach of physical machines that is also undergoing enormous change due to the rise of artificial intelligence. This includes applications like chatbots and RPA, robotic process automation, which I'm sure many of you in this room know quite a lot about. Our report deals only with physical robots, but these same intelligent software systems that increasingly guide these machines will have an important impact on jobs ranging from customer service to accounting to medicine to law. Some of you may have seen a recent study that shows that scanning for breast cancer can often be done better by robots than by human diagnosticians. So this raises the question about what do we do from here? What's the framework from action? What are the takeaways from this? We think there are a number of important steps for educators, governments, and businesses to think about. For educators, you need to be cognizant of the shifting demand for skills across the economy and develop flexible approaches to delivering skill training and education. We have to invest in closer cooperation and more cooperative relations between local industries and educational institutions to better anticipate emerging workforce trends. And people have to share data among themselves so that we can invest in the right retraining and skilling programs so that we can find the talent needed for industry-specific knowledge. Business leaders need to get buy-in from the workforce when making technology investments and recognize that technology disruption or change will bring to many workers' lives and accept some responsibility for it. Workers are also going to have to audit their own skill sets to better understand the balance between unique human skills and those which are automatable, and adopt this mindset called lifetime learning to continue to gather the skills needed to become effective and productive in the next environment. And policymakers, including government officials, really need to think about exploring and analyzing the implications of robotization for the economy, the workforce, and the wider society. And hopefully develop collaborative environments to foster skill development and map out the existing skill sets that exist at local levels so that people can figure out where they exist and where they don't exist. They need to identify the areas most vulnerable to dislocation from the rise of robots and develop aggressive, forward-looking programs to counteract these effects. So let me just end with a few key takeaways. We're living in an era of rapid expansion in robot applications. This is inevitable, it's coming. It's a huge opportunity for growth, for making all of us effectively wealthier. An additional robot per 100 US manufacturing workers means a $185 billion boost to the US GDP alone. Those are not numbers you can sneeze at. But there are profound implications for the labor market and for the potential for social inequalities. Each new robot eliminates 1.6 manufacturing jobs. That could be 20 million jobs by 2020, perfectly possible number. And almost twice as many of those jobs will be lost in lower income areas than in higher income areas based on the robots installed. So policymakers, businesses, tech companies, educators, and workers need to prepare for the policy dilemma of what do we do for those who are left behind, because there's going to be significant political and economic impact from the rise of the robots and the adoption that we see going forward. Let me stop there, and hopefully there's time for questions. Thanks very much.